Hey guys, I'm going to walk you through solving this in-class problem. In the problem we have three spheres. You have A, you have B, and you have C. They each have mass, and therefore they each pull on each other with a gravitational force that we can calculate. You're given a distance, 1.6 meters, that goes from A all the way to C. However, you also know that B is in the middle. So you then know that the distance to B is 0.8 meters. We only care about what's happening to A. A is being pulled to the right with a force from B on A. It's also being pulled to the right from a smaller force from C. C is further away, so the force of gravity on A is less. We don't really care what's happening to B and C because the problem is only asking for what is happening to A by B and C. So these two force vectors that point to the right can be calculated. We have our universal gravitation equation. And so to calculate the force from B on A, it would be big G, the mass of B, the mass of A, over the distance between them squared. When I plug in the values, we have 6.673 times 10 to the negative 11, it's big G. The mass of B is 8 kilograms. The mass of A is also 8 kilograms. And the distance between them is 0.8 meters, and we need to square that. When we put it in our calculator, I'm going to put alpha G, which I've stored as big G, times 8 times 8, and I'm dividing by that distance, 0.8 squared. And I get a value of 6.673 times 10 to the negative 9. And that's going to be in newtons, and that points to the right. Force of C on A is the same equation. Big G, the mass of C, the mass of A, over that distance all the way to C. Again, I'll make that B. So the only thing that really changes here, we still have big G, 6.673 times 10 to the negative 11. The mass of each of them, again, are the same. So our numerator remains the same. What changes is our denominator is now 1.6 squared. So my calculator, I'm going to use my little second enter trick. And now I'm only going to edit the denominator, make it 1.6 and square it. And I get a smaller value, 1.67 times 10 to the negative 9. And that's the force from C on A. Now the total force will just be the vector sum of FB and FC. They both point to the right in the x direction, so therefore we call them both positive. And so I can add the values directly because they're vectors that point in the same direction. If they pointed in different directions, we'd have to set up our XY table and add them as vectors. But since they're both to the right in the same direction, I can add the numbers, 6.673 times 10 to the negative 9 newtons plus 1.67 times 10 to the negative 9 newtons. In my calculator, I've already got the one value in there. I'm just going to hit plus. I'm going to add 6.673 second e to the negative 9, and I get my answer of 8.34 times 10 to the negative 9. Again, that's in newtons. And we'd have to say a direction. In this case, as I've drawn it, we can say to the right, or we can say towards B/C, which is probably a better way to do it because I don't necessarily have to draw it exactly in this order. All right, hope this helps. See you guys later.